Good evening, everyone. Just a quick announcement. I'm just waiting for Keto to join. He said he was running a few minutes late, so he should be joining any second. Once he joins, we'll kick off the presentation. So just hold tight for a second. Feel free to ask questions or chat in the window on YouTube or on the Meetup app. Thanks. Yeah, while people are waiting, my apologies on this unusual time for a meetup tonight. Although the RSVPs were excellent, we had, I think, 30 some odd RSVPs. The meetup was originally supposed to be at 12 today, and that's the time that everything was set up for. However, meetup, for reasons I do not understand, scheduled it for 7 p.m. tonight. So that resulted in a little bit of a rearrangement of mine and also Keto's schedules to pull this off tonight. So we're just hopefully Keto. I just exchanged messages with him about a few minutes ago, so I expect him to be joining anytime. Hopefully, it's not making it hard for him. But that's just a quick announcement. And there's also a delay of about a minute between the video that you're seeing and when it's actually delivered. So there's a slight bit of a delay in there. We're doing the YouTube broadcasting after the Zoom bombing we had last year. So this is our new way of doing meetings. I'm actually working on trying to locate venues for in-person meetings this year. Our location in New Haven, the Hoberton School, actually shut down during the pandemic. So I'm looking for a new site, either in New Haven or up in Hartford. And the company VGO Software that we were using up in Hartford also got bought out by a larger company during the pandemic as well. So there's quite a few changes to that. So feel free to drop me a line if you have a suggestion for either a topic or a meeting location where we should hold meetings back in person. I think there's some value, like the in-person meetings as well as the virtual ones. So feel free to drop a line on that. I think we will continue to do online virtual ones because Keto tonight will be joining us from Virginia, so it makes it easy to pull in long distance presenters doing it virtually, which was hard beforehand, trying to get meeting dates and venues to line up at the same time. So just stay tuned. Hopefully Keto will be joining shortly. Does anybody have any Java questions they want to ask in the chat window while we wait? Just a quick update. Keto's getting an error message right now saying that the meeting is already in progress and it's not letting him join. I hope to have this resolved quickly. Great. Can you hear me, Keto?
Yes, I can hear you.
Great. So, like everyone, I'd like to welcome you to our January meeting. Tonight, Keto will be giving a presentation on GraphQL for Java developers, a topic that I'm interested in. I'm sure many of you are also interested in. Just a reminder, questions up on YouTube or on the Meetup app, I'll try to get them to Keto during the presentation. Also, our February meeting is tentatively scheduled, or the presenter is at least lined up. It'll be Bellsoft on their JDK. They're one of the JDK implementations. So they'll be giving a presentation next month on their JDK. And with that, I will now hand it over to Keto to present. So let me make a host, Keto, and then I'll stop my video. I think my camera is actually smudged, which I just noticed. Usually I have tape over it. Make host, yeah. I don't like it when it like suddenly turns on and I'm not doing anything.
Yeah, that's understandable.
Here you go, Keto.
Okie doke.
Thank you very much.
All right. Thank you, Ryan. All right. My name is Keto. And let me share my screen here. And Ryan, you can let me know if the size looks okay. Trying out a different resolution here.
It looks good so far, and it looks good. I'm also watching the streaming on another screen, so it looks pretty good.
Okay, good. And
a much better background than I do.
All right, and let me refresh this. Okay, so still looks good.
Looks good.
Okay, cool. Okay, so my name's Keto, and this session is called GraphQL Distilled, or GraphQL for Java developers, depending on which conference I give it at, or which user group. So I'll be talking about GraphQL, but I'll also focus a little more on Java since this is a Java audience. And that link there is sort of a permalink to this session. So it has links to slides and a couple. Actually, I think it just has links to slides and PDFs and like a mind map of this presentation. So, all right. So, just a few words about myself. My name is Keto Man. I am the principal consultant at Virtua, where we do consulting, training, mentoring for both front-end and back-end development with a lot of Jakarta EE stuff, just straight up Java microservice stuff, even like, Python and mobile apps and all sorts of stuff. So basically software development and architecture with usually some sort of web front end and Java backend. I'm a Java champion. I used to be involved in lots of Java community process expert groups back before the Jakarta EE split. So that included like CDI, JSF, portlets. I'm a member of the Jakarta EE Guardian Leadership Council with Ryan. And I used to be a Google developer expert in web technologies, focusing mostly on web components. I also am the co-host of a podcast. So if you like podcasts, you should check it out. There is, it's called Stacked Podcast. And basically we focus on front-end and back-end development, obviously with an emphasis on Java, but just general software development, front and back. And we usually have people from the industry as guests as well. So it's always a good fun. So if you like podcasts, check that out on your favorite podcast app. Also, I recently started a site called Speaker Tracks. We're working on it, and actually I'll be talking a little bit about it in this session. And it's just a tool to help speakers keep track of their sessions when they're submitting to conferences and user groups and things like that. So that's a little bit about me. This is, I think, where I'm going to need some help from Ryan. I wanted to get a sense from the audience, like how many of you like currently are working with GraphQL versus are totally new to it, or maybe just have some familiarity. So if you could put in the chat, like, sort of where you are in that spectrum, that would be helpful.
It's good. There's about a 30-second to a minute delay actually between when we talk and when it actually appears on YouTube.
Okay. All right.
So we'll have to kind of like so questions over there will be delayed a little bit. So
okay.
we'll know in about 30 seconds to a minute.
Okay. So what I'll do is I'll start going and then I'll stop for a second for you to answer. Okay. So let's go to the next slide. All right. So I'll start with just a little bit about what GraphQL is. And in its simplest format, or the simplest description is just it's another way to do client-server communication. So you basically send a request. The request tells you what data you want. On the left here, we have a hero. We're saying we want all the heroes, and we want just the names of the heroes. We don't want any other data back. On the right, we return the data, and it has the hero and the name, and that's it. Obviously, in this example, this just has one hero, but there could be multiple heroes as well. And so it's a very, very simple example. It was actually, well, a few key things here. First, it doesn't use REST. So that's a key point. It's not based on REST, doesn't based on SOAP or anything. It's just a completely different way of doing client-server communication. It was started by Facebook in 2012. And regardless of what you think of Facebook, they do have some good technology. So it made a lot of sense for them because you can imagine they were really trying to handle graphs of data, because that's essentially what Facebook is a huge graph of lots of data. So they open sourced it in 2015. And in 2017, the GraphQL Foundation was created. And this is really sort of the initial starting point. If you want to just learn about GraphQL, it's graphql.org. That's where the foundation site is. And there's lots of information there. And that's basically how the technology evolves. So there's a specification, and there's a decent number of companies working on it regularly. It's also used by lots of large companies. So if we go to this link, oh, guess that link is dead. Lovely. All right. But you can see here we've got Lyft, Twitter, Starbucks, PayPal, Intuit, GitHub, lots of other companies work with it. So so it's definitely pretty heavily used, especially for a lot of larger companies, but also smaller companies as well. So with that, Ryan, did anyone get back to you?
Yes, we got a couple of basic knowledge only, used it on one project so far.
Okay, all right, that works. Cool. All right, so let's go to the next slide. So so that's basically, you know, at a high level what it is and where it comes from. So let's talk about in a little more detail, like why you would actually want to use it. All right. So here are some of the benefits. First, it's a single consolidated dynamic data point. Dynamic endpoint, excuse me, not data point. It's been a long day. So basically, instead of having a whole bunch of different URLs that are different REST endpoints, with GraphQL, it's pretty much just one endpoint, and then there's an API, and the API is, you know, depends on what you've implemented on your backend. It has subscriptions, which is a really great feature, and this allows you to actually push data back to the client or to the clients, as opposed to just having the clients retrieve data. It has a defined data format, which means that every GraphQL application, you know, represents data in a certain way. Whereas with REST, you know, REST doesn't really care about the data format. That's really just an implementation detail. It's more along the lines of something like SOAP, although a lot less heavyweight and stressful to work with. But there's a specific way that you define the data. And on top of that, you have a typed schema. So whenever you have a GraphQL service or GraphQL API, it has actual types defining the data that you can request from it. Another big difference is that the client decides what data it wants. And what that means is that, you know, in the first example, we said we wanted a hero, we wanted a name from the hero. Well, on you know, the client is saying, I only want the name back. It's saying I don't want all the other information about the hero. I don't need its ID. I don't need to know, what planet the hero is from. I don't need to know any of the other information. And what that means is that the client can actually reduce the amount of bandwidth that's going back and forth, or that's being utilized going back and forth, and then also can parse less data. So it's actually more performant in that respect. So the client decides what data it wants. The server decides where to get it. So in a simple case, the server might just be a microservice that's talking to a database, and that's fine. But it could also be an API that's been built with several different services behind it, and that's usually what we call a backend for front end. So maybe that API was designed to work well with whatever the clients are, whether they're mobile or web or a combination of the two, and then that there's that API layer, and that API layer maybe it talks to other services. So you can use it as an aggregation layer as well. So of course, it was designed to handle or to overcome some of the drawbacks of REST. So these would be things like, the endpoint decides what data is returned. So, maybe you only need that name property on the front end, but the endpoint is returning tons of extra data. So then you're using extra bandwidth, and, your client has to deal with, throwing out lots of data. Sometimes in a REST API, the data is split up amongst several different calls. So you'll have the front end, having to make like 3, 4, 5, 10, 15, 20 calls just to render one page, which, is good and bad depending on how things are designed. There's no specific data format. So when you have a REST endpoint, the data format, you need to sort of figure out what it is. Is it normal JSON, and how are you actually representing that data? And of course, the data that's returned depends on the endpoint and who implemented it. So sometimes people implement stuff differently, and you have issues there. And of course, REST doesn't define an actual push standard, because it's just not part of REST, but it is part of GraphQL. So those are some of the drawbacks. So this might be a good time for questions if you have any, Ryan.
Not yet. No questions coming through yet.
All right, cool. All right, so let's look at a quick demo, and this should give you a really good flavor about, sort of what GraphQL is and how it works. So just like with REST, there's, several different clients you can use just to hit a GraphQL endpoint and make requests and see responses. And Postman actually does do GraphQL. The last time I looked at it, though, it didn't do a very good job at it. So that may have changed. It's been a little while since I've worked with Postman. But I've been using this one called Altair, which is available as a Chrome plugin and also as an Electron app. And it's not as super full feature as Postman, but it does get the job done for GraphQL pretty well. So I'm going to look at a few specific examples here. So we'll start out with a basic query, okay? And Altair will complain here. So what we're looking at here is a simple query up here, and you'll notice what we're looking for are issues. So, and if you notice up here, I'm looking at the GitHub API. So GitHub has a really extensive GraphQL API, and we'll be using that for some of our examples because it's really powerful. It's a good example of a production-grade GraphQL API, and it's something that most developers are familiar with, so it works well for demos. So here we're doing a query. We're getting all the issues back from a repository owned by Prime Faces, which is an old Java Server Faces framework. It's actually still around. It's still being used a lot, actually. But we want to basically look at the Prime Faces repo. We want to get all the issues, and we want to filter by the open issues, and we just want the first 50. So we can do this query here. I've already got my I got a API key from GitHub, which you can get for free. As long as you don't use it too much, you're good to go. And you see I get this data back. So on the right here, we have this data element, which is the first one. It's coming back as JSON, and it tells me the repository, and it gives me the name of the repository and then all of the issues. And you see the issues, it's giving me essentially a graph structure. And this is not something that GraphQL requires. This is just an implementation of the schema, but they are representing elements as edges and nodes. So you can see these are all of the issues coming back. So different issues coming back for prime faces. This is a total coincidence, but I happen to be wearing this shirt here. This old, oops, I disappeared. This old prime faces shirt from like 15 years ago or something. So it's just a total coincidence. Anyways. So this is a simple example, and when I see this stuff, I'm always thinking, okay, what does it actually look like at the network level? So what's actually going on? So if I make this request here, okay, on the right here, and I'm not donating right now, okay, you'll see there's this GraphQL endpoint, right? And this is one of the points I was trying to make earlier, is that essentially this is like the endpoint. Like all the requests are going to go to this API github.com/GraphQL, but they're all going to be post requests, and then just the data in the request is going to change. So if you see here, the payload that we're sending is the operation name, which is issues, and then the actual GraphQL query, and then any variables, which we'll talk about in a minute. And then the response we get back, of course, is what you see on the left here. Okay, so it's just a normal post request, uses HTTP in this scenario, and you get back a JSON payload. But the JSON payload that you get back is always going to have this data element at the beginning and then the actual data back. Okay, so that's a very, very simple example. So let's look at another one. So here we're going to get all the repos back, sending the query. So this is using the search query. And the query that we're going to send it is GraphQL Java. So we want to get all the repos back with that match the queries GraphQL Java. And the search query is sort of generic, right? Because you can search for anything in GitHub, right? So you need to specify additional parameters. And these are what we call input objects in GraphQL. So we want to specify the type. We want to specify the other things like how many records to get back. And you can also, of course, request like the next 30, et cetera, et cetera. But since this is a generic query, we need to specify the type that we care about, right? So we say we want it to be a repository, and then when we get a node back, we want to say, okay, for responses which are a repository, which of course all of them will be in this case, we want to request these properties back. So let's run this one.
Quick question: what are the three dots that are in front of the on repository?
So we will get to this later, but this
Okay.
is something we call a fragment.
Okay.
Yeah. So.
And we have a question about an example for a push for GraphQL.
Okay, so we unfortunately my demo for that doesn't work, but I will go over how it works. So, yeah, I've yet to find a very good example for that. So when we say the repository here, we specify the properties that we want back, and you see on the right hand side we have name, stargazer count, etc. Wow, and this has 5,725 stars, which is pretty decent. GraphQL Java, just so you know, is essentially the it's sort of like the workhorse of every single GraphQL implementation on the Java platform. So sort of like, when someone solves a difficult problem, everyone just builds on top of it. They're like, okay, the core is solid. So GraphQL Java is sort of the baseline. It's a lower level API to work with, but it's really powerful. So this is an example of the response there. You see we've got some other ones there too. GraphQL Kickstart, which is also a good place to find some Java tools as well. And of course, there's lots of other ones as well. So this is also a good thing for you to see, all the different options there are in the Java world that are related to GraphQL. There's quite a few here. So, okay, so those are a couple of simple queries. And this is the same sort of thing, but you see we're specifying a different type here. Okay, So here we want to get all the issues back for that have GraphQL in them. Oh, this is great. It doesn't work with GraphQL. And you can see the repository it's from as well. So this is just handy examples. Let's look at some other ones that are a little bit more complicated. All right, so we look at basic queries next. Okay, so over here we have actually, we actually started out with basic queries instead of the simple query. So you're good now in terms of understanding the slightly more complicated queries. This was the initial one, but it's the same idea. Okay, so after this, we want to go to fragments and variables. Okay, so let me just do something here. Okay. So you saw initially we had this variable being sent that was empty for that query. Variables allow you to parameterize a query. So in this example here, we have a repo. We're doing a query against all the repos at GitHub, but the query we want to be a variable or a parameter. Okay, so we can specify here. This is the query we want. So now we're saying basically, okay, give me all of the repositories that have this query variable. The variable value we want to use is actually circuit breaker. So we're basically looking for all of the queries with a circuit breaker in them. So see how that looks. Looks exactly how you would expect. And what's happening is the way this is sent. We'll go back to the network here. Okay, now we have the variables being fit in. So the GraphQL engine is going to basically parse this, say, okay, now I want to be able to, now I'm expecting a variable called query, and then I'll insert that before it actually processes the actual query. So this allows you to, on the front end, or even if you're doing, service-to-service communication using GraphQL, you can actually have one query and then parameterize it easily, which is nice. Okay, so we also talked about fragments. So this is the example we had before, right? This ... here. We could also do it this way. So basically, we're saying we want a fragment which is on repository. We want to basically say this is something we can reuse. So anytime we want to be able to essentially pull out properties for something that is a repository object, we can do it this way. This allows you to write a query like this. Okay. So we basically have pulled this out into a section. And this is basically the ... is being used to say, okay, on this particular type. Okay. So this is going to look pretty much the same as what we saw before. So we've got all the different GraphQL endpoints or GraphQL repositories coming back there. Okay, so another thing we can talk about are directives. So directives are basically a way to extend GraphQL, your GraphQL queries language, essentially. And basically it's saying, it gives you an extension point so that you can put at whatever and then do something special on the server. There's only two which are built in. There's include, which is handy for including sections of a query. So this is saying basically we want to send in a variable called show language. If the variable is true, we want to get the name of the language or the name of the repository, actually. And the other built-in directive is skip, which is pretty much the same idea. You can skip a section if you want to. So this would run pretty much the way you would expect it. And the variable value we're using is show language true. So that means that we should get the name of the language down here. So we see primary language and the name is Go. So And now there's really, if you didn't include this, you just get nothing back. So you see that whole primary language was excluded. Okay. So that's sort of a very quick tour of GraphQL queries, just from a high level. Now, of course, if you could only query data, even though it's called GraphQL, only if you couldn't actually write data, it would be sort of limited. So there's also the ability to update data, and those are called mutations. So here is an example of a mutation. And what this is going to do is create a new GitHub issue, and it's going to give it, add it to a certain repository, which is my own repository. And it's going to give it the title demo and the body demo. And then every time you execute a mutation, you can also get an object back. And usually it's the object that you created. So here I get the issue back so I can query and see what that was. And what's interesting is even though I'm only sending in this data in this input object, I'm getting back other stuff, right? Because it's whatever the server returns. And so it can tell me what the author is as well, because I'm the author, but it's good to see that that's the metadata that's being associated with my issue. So, and what I'll do here is I'll say the title is hello CTs or CT jug, right? And I'll say for the body, I'll say I used to live in Stanford. So yes, I was there until about 9 years ago. That's actually where I met Ryan. So, okay. So I've created my issue. The author is, of course, me. And then here's title and the body. And let's see if I can actually find this on GitHub. So the repo is called GitHub repo list, which is a demo from a different presentation. But let's see if I can find it. There it is. There's my issue. So I very, very easily use GraphQL to add a GitHub issue to my my own repo. So very exciting. Okay, so that's an example of a mutation. So those are sort of some basic demos, which should give you a sort of basic idea about how things work. Let's talk about something else now. So I said before that we have what are called schemas, right? Which is a typed contract between the client and the server. To me, this is one of the best things about GraphQL is that I don't have to use OpenAPI to come up with a way to define all my types. It's built into the way GraphQL works. So in addition to being that contract, that type state contract, a key point is that the client can only request the data defined in the schema. So the client cannot request other stuff. And that's something you can sort of enforce with OpenAPI. Well, you can enforce that with OpenAPI, but it's sort of a core tenet of GraphQL. You have to stay within the rules that have been defined by the schema. Another key difference between GraphQL and REST is that the endpoints, when you want to evolve an API over time, you can't, well, you could actually do the versioning with V1, V2, but you're really just supposed to use deprecation. So basically, as part of the query language, you can deprecate any property, any type, etc. And that's what you would do. And, to me, that's good and bad. I think it's a lot easier to maintain for the people building out the API, but it's harder to get rid of stuff because it's hard to get people to stop using stuff once they start using it. If you just deprecate it and it still works, they tend to just continue to use it. So I think that it's good and bad. Okay, so let's look at a demo of the schemas. Okay. Sorry, I was looking at this other screen here. Oh, that's what I wanted to do. Okay, so what we're going to do is take a quick look at the actual GitHub schema for the GitHub GraphQL API. So let me make this slightly bigger here. Okay. So this is the GitHub API, and you see it's because you can actually download this from GitHub. And you can see it's actually quite large. So if I go to the end, it is 40,000 lines. So it is a huge schema. This is way beyond what most organizations will use, but it's an example of a very powerful, large enterprise grade API. You see it's already got a couple directives defined up here. So these are directives that are defined here, but the server knows what to do with them. And the support for additional directives above and beyond the default 2 depends on your server. So it could be something you implement yourself, or it could be something that's provided by some other API or some other framework that you're using. But let's start out with the query. So that's what I want.
Just a heads up, we had a question on performance, which is better, REST or GraphQL?
Oh, you know I'm a consultant, right? So my answer is going to be depends on the use case. Yeah, it really depends. I will say, in raw, if you're just doing something very simple, GraphQL is a lot of overhead, right? But that overhead may not matter what you're doing. But again, it's going to depend. The reality, though, is that there is more work going on before it gets to your code. So that's going to add some overhead. But, depending on how things are built, it may be faster, especially if you're optimizing your data fetching and all that kind of stuff. So
yeah, I think I saw there was a video on YouTube. I forget the organization that did it. It was a real interesting overview of how GraphQL came into existence. And it was, I guess, how Facebook sped up their mobile application.
Yep, that makes total sense.
So I think where you're pulling back random bits of information and not doing, lots and lots of REST calls to retrieve, to build up a screen.
Yep, exactly.
So
and that does give you a lot of benefits, right? So even though maybe it takes slightly longer to process the requests, if the overall round trip and everything is faster, then you get those gains. So right, this is what I've been trying to find. I don't know why my search wasn't working. So every GraphQL schema is going to have this root type called query. And it's basically all of the queries that you provide in your schema. So this is the root query, and we were looking at repos, right? So this is the repository query. And you see we've got comments here. And these comments serve also as documentation. So they can be used by tools and also for development. And you see we specified that we want the name and the owner are the inputs, and then returning a repository type. And so if we look at the repository type, it implements all these interfaces. So we also have interfaces. So another thing I like about this is it's very, very friendly for object-oriented people. So it implements all these interfaces, and then it has its own types. And you notice that we have, for assignable users, you see we actually can specify other properties, right? So when you specify you want properties back, sometimes those properties require inputs. And those inputs basically decide what data is going to be returned, right? So this is not going to give you all the users. It'll give you the ones that you filter, that you want to get back. And so basically, anytime you request a property, you may or may not have to specify additional input parameters to decide how you want to filter that property. So this is, a pretty good example. We've got comments, collaborators, and you see all of these different ones have the ability to do the pagination here. So you have after, before, first, last. And this is not something, again, that GraphQL requires. This is just how the schema was defined. Obviously, if you don't have that much data, you may not need to do a pagination. So that's the story there. Let's look at we look at the repository type, let's also look at one of these. So if we look at, let's say, Starable interface, we see a Starable thing has an ID, and of course it has a Stargazer count and a list of all the Stargazers. Okay. And of course it has a Boolean. And this exclamation point here basically says that it's required. Okay. So that's an example of another interface, right? That, of course, this doesn't work unless something implements it. So a type is what is returned. You can't return just an interface by itself. And there's also some primitives. There's a Boolean, there's ints, there's a couple more. There's no primitive date, which I find interesting, but logical, et cetera, et cetera. There's also enums as well. So if you wanted to see the star order, could have the direction of the stars. Let's see, sponsorships, sponsorship privacy, private public, etc. So you can build up a really rich vocabulary that you can use, to work with the front end and the back end as well. So this is an example of a schema. Now, what the schema lets you do, other than, of course, allows you to communicate with the front end and the back end, depending on what side you're on, it lets you actually communicate with tools as well. So this schema defines all the types that are provided by the API and all the queries and all the mutations, etc. If you use a tool like Altair or any other tool that's GraphQL aware, and you're actually able to switch to your browser, okay, you can get some help. So I'll go back to basic queries here. So I never clicked on this before, but it's this little docs tab here. Okay. So this gives us all of the queries and mutations that are available on this particular GraphQL API. And it uses all those comments that we have as documentation. So here I've got the query, code of conduct, enterprise, all the different things that we just saw. And this allows you to basically go and navigate in between them. So they navigate there. Let me go back. So we were just looking at repository, right? So we can go to the repository query. These are the properties, or these are the arguments, which are essentially input objects that are required, which we just saw. We saw that returns a repository, and these are the fields in the repository object. Okay. So this gives us really good documentation out of the box just by defining the schema. And then on top of that, any good tool can actually use that to help you write your queries. So here I am writing something for an issue. If I just ask for code completion, I can find, oh, okay, well, I also can get back to the author of the issue. And then what are the properties? Well, I can fill out all fields, right? Let me get rid of that. Okay, and it looks like there's a bug there, but it should fill an off field. I guess it doesn't really want to. But assuming you don't have a bug, you can say, okay, I want the login, I want their avatar URL, etc. Okay. And then, of course, you can go and find, okay, well, what else do I want from a repository? I also want to know if auto merge is allowed, or I want to know, is I don't know, what are some commit comments or collaborators or things like that. So you get full code completion based on the schema as well, which is very nice. Okay. So the schema gives you a lot of things. It gives you a type safe way to define your API and communicate with both front end and back end, whether it's same team or different teams. Gives you, if you write it well, it gives you full documentation for your schema as well, and also gives you integration with tools. So it's a really, really powerful feature. So that's the story with schemas. Okay, so let's say you have gotten this far. You're like, say, okay, this is cool. You want to start building something. How do you do it? Well, there's a couple different design approaches. One is what we call the schema first approach. And that's where you sit down or stand up like me, and you basically define the schema up front. And this works really well if you're working with two different teams or multiple teams that need to collaborate on what the API looks like before you spend a lot of time writing code. And what this also allows you to do is, maintain the schema separately if you want to. I was on one project where we had a separate repo for the schema, which the front end and back end teams worked on together. And we also did code generation from that same repo. So we would generate TypeScript front end code and Java backend code from that repo. And that worked out really well for that particular team. So that's helpful in situations where you want to do that sort of upfront thinking. However, the other approach, of course, is code first, which is usually where you build out the backend and the backend automatically generates the schema. And this is helpful in situations, let's say you've got more of a backend heavy team, or you don't need a lot of communication and collaboration in terms of finding the schema. You just want to start building it and generating it and then iterating quickly. And code first works well for that. The other benefit of code first is that there's more tooling out there, or more like libraries and frameworks for working with it. There's certainly schema first stuff, but there's just not as many options. So that's something to keep in mind. And of course, either one, they're both perfectly valid depending on, but you need to just think about it for your use case and whether or not, it makes sense. And also you got to make the decision up front. You can't really do it later. I mean, you can, but it's expensive, right? You got to throw away a lot of stuff and start over with some aspects. Or if you're doing code first and you're switching, you could theoretically take what you generated and use that as a starting point for a schema first approach. But it helps to kind of do it up front. So that's the story there. Okay, so that's those are some of the approaches for designing the schema. I should also mention subscriptions. So as I said earlier, subscriptions allow you to push changes to the client. And the idea is that the client says, in being true to the spirit of GraphQL, the client says, I'm interested I want to be notified when there are new changes to these properties on this object. So that way it's basically has the same idea, but it's just that you make that request and then you get pushed back those updates as they occur. And one of the cool things about it is that it's transport independent. So you don't have to use any particular protocol. You could build out stuff and then decide, or change the protocol over time. The most common one is WebSocket. You'll find a lot of implementations for that, but it could be anything. It could be anything that handles messages. So I've seen MQTT for IoT stuff out there, service and events as an alternative to WebSocket. And there are several other options out there as well. So it's a pretty powerful feature. And to me, this is actually something, if you just wanted to use push in an application, it's a pretty good use of GraphQL. And on the project that I was on, that I was talking about before, we ended up using it because it actually wasn't our initial plan. But the requirements evolved to the point where we really did need to push out changes, and it worked out really well for that. So I don't have a good demo of this. Hopefully by the next time I do this presentation, I will, but I will show you what one of these looks like. So if we look at a subscription, you'll see it looks pretty much the same as what you've seen before. So instead of saying query or mutation, you just say subscription. And then in this example, actually I had a different example, but it doesn't really matter. Here's the other one. Either one of these could work. But here we're saying we want to we want to create a subscription. We want to be notified whenever there's a new random person. And we want to get the ID and the names of that person. Okay. This one is a similar one, but it's the same. It's just basically has a different subscription that it's talking to. And the way that you implement this really is going to depend on your framework, right? Because they have different ways of doing it. But at the end of the day, it's going to be some sort of observable, completed future. In Quarkus, it's a uni from their Mutiny framework. some sort of streaming object that you'll need to return, and that you basically need to populate with the data as it comes in. So that's the story there. The APIs make it very, very easy to do. It's just a matter of, finding the right implementation and everything. So that's my story with subscriptions. Okay, so one of the other things I wanted to mention was federation. So federation is basically the idea that you can have multiple GraphQL implementations that are being exposed by a larger GraphQL API. Okay, and you'll find that there's one. And federation is not like an official standard. It's basically a feature of Apollo GraphQL, or it's defined by Apollo GraphQL. And Apollo is a company that has a lot of GraphQL products, and they're basically the same way that there's GraphQL Java is the de facto standard for Java GraphQL implementations. Apollo's GraphQL API is essentially the default standard for anything in JavaScript. So basically, almost like a lot of implementations in GraphQL on the front end lead back to Apollo. So they do have this thing called Apollo Federation, and you'll find that other GraphQL implementations are starting to support it. So the basic way I thought to explain this was to look at this picture I had of what's happening. Let's see if I can make this a little bit bigger. All right. This is the journey of, make this bigger, of Netflix. So Netflix used GraphQL for their studio application. So I don't know if they use it for their main, the one that we use as consumers, but this is used behind the scenes for managing all of the content that they're building. So initially they started with a traditional BFF, initially they start with direct access. This is what we usually have, right? We have all of our client apps, and they are all talking to different services, right? Different endpoints. This is what we have in general. The BFF pattern lets you basically provide that standard API and then have that API make those additional calls. Those services can still talk to themselves, but it's a little bit simpler in terms of what the clients have to access. And this was their sort of second iteration. But then they went to this federated gateway concept. And this is a little different, right? So here, a lot of these endpoints are probably just REST services. So that's commonly what's done in a BFF is you just build a GraphQL API and have it call whatever REST endpoints it needs to call to get the data that it needs and do the operations it needs to perform. With the federated gateway, you basically have your overall API, and then you talk to additional GraphQL endpoints. And these GraphQL endpoints are smaller subsets. So they could be different groups or different features, things like that. And they will provide a GraphQL API. And what this is doing is essentially stitching together all these GraphQL APIs across them. And there's actually, it's ironic because I kind of wonder what happened to this, but there's a session I saw which came out, I think it was last year or the year before, where Twitter was starting to do this. And they had a sort of a somewhat over-engineered but powerful API for doing this so that any given group could very easily publish a subgraph to the overall graph. But that's the basic idea. So federation allows you to take several smaller GraphQL APIs and present them as one big GraphQL API. So again, that's only useful in larger implementations, but still very handy. Okay. All right, so let's say you're interested and you want to actually know some details, because that's always my question. It's like, okay, that's cool. How does this actually work if people want to do it? So there are lots of GraphQL implementations. And on the client side, you'll find there are lots of different languages. This is true for front end and back end. There's tons of languages. Obviously, we're more interested in Java here, but if you work on a team where there's some other language that's being used, chances are there is an API for it. So there's lots of JavaScript stuff, of course, but there's every other language you can think of as well. So for JavaScript on the front end, well, this is the server side. Apollo. And then on the front end, there's Apollo Client. There's AWS Amplify. AWS has a lot of GraphQL stuff now. And there's other ones. Relay is one which has been around a long time. It's from Facebook, but most people think it's overly complicated for most applications. You'll find, of course, there's a lot of React support because everybody loves React, which that's all I have to say about it. So there's lots of stuff on the front end. So Apollo Client, as I just scrolled by, that's the most popular one you'll see. So they have direct support for React, but you can also use it with other front-end frameworks as well. And it's really full featured. It has caching and all other sorts of cool features in there as well. There's another one which I like called Apollo Elements. So I'm a big proponent of web components, which are basically just a standard component model that runs inside web browsers. It allows you to write components that work with different web frameworks. And Apollo Elements gives you that approach on top of the Apollo client. So if we were to look at, we'll go back here a second. So if you want to see what Apollo looks like, let's see. I thought I had a quick example here. Okay, here we go. All right, so here's a very simple example. You say client query. They have this tag template literal called GQL. This will let you just embed queries, and you can also parameterize it and all that kind of good stuff. You can throw it in here, and then you're basically, excuse me. Okay. So basically, you basically create your query here, and then here we're passing it through, or basically making the query and getting back a promise. And of course, you've already specified the server you need to talk to, et cetera, et cetera. So that's basically the idea here. This is the actual implementation of the client, or the main object, the Apollo client, that gives you the URL you're talking to. So it's really straightforward, easy to use. It has this great caching feature, etc. Apollo Elements builds on top of it and gives you a declarative way of handling this. So inside of an HTML page, you can actually create a GraphQL query this way, and this is the declarative way. And then you can also write code as well, which I'll show you a little bit later. So I like this approach as well. So those are just a couple of approaches on the front end. I'm sure there are, well, as you saw, there's dozens more. So let's talk a little bit about the back end. So in the world of Java, as I mentioned before, GraphQL GraphQL for Java is sort of the main sort of workhorse. But you often will use something else with it. So GraphQL Java Tools is handy. And what it lets you do is basically use a schema first approach. So this is what I used on one project, was to use GraphQL Java Tools to help me do schema first stuff, which is nice. So this is one option, and I think there's another link. There we go. GraphQL Java Kickstart there. Now I found the snooze button. Woohoo! Okay. All right, so it gives you the schema first approach, and there's examples and stuff here. So this is fairly, it's not really super low level, but it doesn't necessarily integrate with there's integrations for different tools, different frameworks. I think Spring is one of them. I used it with Drop Wizard a while back. So this is a fairly new one. It's called the Domain Graph Service. It's from Netflix. And it's fully featured GraphQL server built on Java and Kotlin and runs with its integration with Spring Boot. So gives you the Spring goodness when using annotations. So you basically just write your code, throw some annotations on top, and magically you're good to go. Of course, it's always more complicated than that, but they've also have integrated unit tests, which is nice. And you can also it'll generate types for you as well, or your schema as well. It also does federation and subscriptions using WebSockets or server-side events. And file uploads, which is not a very common GraphQL thing. So that's kind of cool. Actually, I think the way we normally approach file uploads was we just do it as a REST endpoint because it's not built into GraphQL. So, so this is a really good option, especially if you're a Spring Boot shop. And it's really, it's obviously battle tested. And you know, it's been around. I think they released it in, I want to say 2022. Or it might have been 2021. So that's one option. Another option is microprofile GraphQL. So if you're in sort of the microprofile Jakarta-E space and you're using Quarkus or Halidon or something like that, or WebSphere Liberty, or even Pyar. Actually, Pyar doesn't support it yet, but all the other ones I mentioned do. You can use microprofile GraphQL, which gives you support gives you a server-side API, client-side API, and of course the combination of the two. It works well with Quarkus and servers like that. It's not as full-featured as the DGSs by any means, but it's really a good, decent implementation that you can work with as well. So, and that's actually what I'll be demoing later. Spring also has their own GraphQL implementation now. And again, all of these, except for maybe the Netflix one, used the GraphQL for Java underneath. But they have Spring for GraphQL, which is a successor. There was this GraphQL Java Spring project out before. And this basically will allow you to write your code write everything using pure Spring stuff, and also does subscriptions via a WebSocket as well. This looks pretty much like you might expect things to look in the Spring world. So pretty straightforward there. Also has GraalVM support, which is nice. So those are some options there. There, of course, are others, but I'm guessing you probably would end up with one of those if you started out on this today. On the server, there's Apollo server node for JavaScript stuff, which of course supports Apollo Federation. GraphQL Yoga is another one which is popular as well for backend Java, or JavaScript, excuse me. Okay, so let's take a look at another demo. And this time what we'll do is we will look at a GraphQL implementation using Java on the back end. And actually we'll be using Quarkus. And on the front end, it uses web components using TypeScript and the Apollo client. I had another demo I was using for this, but I decided this time to use the speaker track site that we've been working on. So I've been working on this with Ballast C, who's done a lot of Jakarta-E, JSF stuff back in the day. And what this app does, it'll let people manage sessions and stuff, but what I'll be showing today is just a very simple front end. So so I'll show what this site looks like. So this is basically a speaker profile page. Okay, and this is what we're going to be demoing. And on the front end, this is a web component. And basically, this is a fictional speaker. You've got publications, you can click on them, you can go to the link, which I didn't mean to do. And then you can look at the sessions that they have. So these are all the sessions. They have different tags you can apply. You can filter it, you can change the layout, and then of course you can make another query here and go and get more details about the session here, and then see previous places where it was presented, all that kind of fun stuff. So this is what their front end looks like, and what's happening. Look at the network side of things. So I'll just do the initial refresh here, and you'll see there's a GraphQL request, and this GraphQL request here is looking for it's getting the speaker profile by ID for bio. So that's the name of the query, and what it's looking for is part of the speaker profile. So it's getting back the speaker profile that has this information here. This other query is getting back a little more information. It's getting back the headshot, the social profiles, and the speaker, whereas this one got back some other stuff like configuration stuff, some sessions as well, but this one is not getting back quite as much stuff. Okay. And then when I go, so what's happening is all of these filtering is just done without any other queries, because there aren't that many sessions. You can do this all in memory. But then when we go to details, we make another query, and we're looking for a speaker session. And this one has a variable that's being sent in. And the session that we get back has all the artifacts, which are things like slides, demos, etc., formats, speakers, etc. Okay, so that's what's happening at the high level, right? Now, there obviously are two parts to this, so I'll start out with the server part because this is a Java audience. So let me close that. Let me open this one. Okay. So what I've got here, and I'll make this full screen, is a simple Quarkus app. And if we look at the POM, you'll see it's all Quarkus stuff here, Quarkus platform, some Quarkus dependencies for Jackson. This uses Postgres, so it's got it also uses Flyway for migrating schemas and stuff like that. But not a lot going on here. Commons, JUnit, so there's not a whole lot in here. And the GraphQL part is this. So small-wide GraphQL is a GraphQL microprofile GraphQL implementation that is used by a few different servers. So this is basically all the GraphQL stuff in here. So then once you've done that, you can then add annotations to your code and magically get a GraphQL API. So if we look at here, there's a couple different API classes, which are like resources. And there's a speaker profile API here. And so instead of saying resource, we say GraphQL API. You can use your normal CDI injection. Obviously, if this were a Spring thing, it looks similar, but it's the same idea. And you basically say, okay, so for any given query that I want to, any given data that I want to expose, I can use this query annotation. And then this will get built as part of the schema. Okay. So I've got my speaker profile. And I can also get speakers and other things, but this is of course the root, because this particular part of the app just displays the speaker profile, right? And this uni here is only because we're using Quarkus, and this is how you do reactive programming in Quarkus. So there's nothing about the GraphQL support that requires a uni. I could return a normal speaker profile if I wanted, but we just happen to be using the reactive APIs. So so what's happening here is this database is this normal session factory from Mutiny, which is basically the reactive APIs for Hibernate. So think of this like a normal Hibernate session, essentially. So basically, we're just returning data back. Now, you'll notice that we also have these other queries here, like speaker, headshot, etc. So this is how you basically create a more complicated query. So we're returning speaker profile back, but we also want to be able to populate the speaker if someone asks for the speaker as a field, right? And we want to be able to populate the headshot and other things as well, okay? So that's what this source does. This basically says, if you're grabbing a speaker profile and the client requests a speaker, then use this method to get the speaker. Okay, and you'll find there's, you see there's a few of these. This is how we basically string together multiple methods to return a full graph. Okay. So so I've got this running here. All I did was I ran the Quarkus dev. Now you can see it down here in the terminal. That's the database. This is the Quarkus. And what's cool about Quarkus is it has this live coding mode that you can just use. So I can make a change here, and it actually does work to you know, make a quick change. But this is the Quarkus console. It's running here, and you saw me use the front end. But of course, since this is GraphQL, I could use a tool to access it as well, right? I could use anything like Postman or Altair, which I was using earlier. Also, what you get with pretty much any GraphQL implementation, you actually get something else, which is a built-in sort of query client. So this is called GraphQL UI. GraphIQL is often included, and this gives you basic support. So if we look at our documentation explorer here on the right, you can see we have query mutations, and we see all the queries that are provided. Okay, and this is the example of a code-first approach. Microprofile GraphQL does not support a schema-first approach, unfortunately. But just by writing that code and providing these annotations, we get an actual API and documentation. Of course, there's not a whole lot of actual docs in here, but this gives us the idea. And then we can still do our query if we want to do a speaker. Let's see, query profile, speaker profile. You know, we can still do all the basic stuff that we did before, right? So we could do that and then get some data back. However, I do find Altair to be better. So this is a decent starting point, and this is actually built in. And what I do like about Quarkus is if you do this, you just go to the default Quarkus page, which I think I can get to here. Yes, you get this dev UI, which gives you each little extension and then different things. So you can see the schema, which is there, and then you can get the little UI, which is handy for testing. But Altair is better, so I'll use that. And I'll go over here. And what you'll see here is that same sort of get profile query. I'm saying speaker profile ID is 1. Let's see what that happens with that. And lo and behold, we get John Doe. Okay. So this gives us back that same speaker profile we were just looking at in the UI. And we specified which fields we want. So we've gotten back the bio, which is the detail about John Doe, his blog, his job title, and his sessions. Okay, and we just got back the names of the. Actually, no, this is one session. Yeah. Okay. So for each session, we're asking for. We're filtering by the visible sessions because he has some invisible sessions, and we want the description and the tags. So we've got tag enterprise Java, Jakarta E, Java, Java EE, and then he's got other ones with different tags. So this is an example of us actually hitting the query just using, you know, a normal tool. And this is an example of us doing a mutation. So I just showed you the method for getting the profile, right? This is the method for doing the mutation. So this is the person API. And again, this is just normal CDI, injecting the context here. This particular context, though, is a GraphQL experimental feature, okay? And this is very handy for getting some more information about the request, which is also very handy for error handling. So that's why we've injected it here. But this is the method we want to call getPerson, okay? And you can see it's not null. a long ID, and then we just basically are returning this find method, which is going to find it in the database for us. Okay. So if I go back here, which will never work apparently, I can add my person. Actually, I'm sorry, I have to show the wrong method. I meant to show add person or create person here. This is the one we want. And this create method is a utility method that creates an object for us. So, and you notice the input here is a person input object. So this is how you define an input object in GraphQL, macroprofile GraphQL. And you see we can also use records, which is nice. So, all right, so go back. And here we're going to add that person. Okay. And we're giving them a name. We're going to foobar as.com. And I'll get back the ID. And lo and behold, there it is. We get back the person and their ID. And of course, we could specify other fields we wanted to have back as well. Okay. And again, that was calling this method. And you'll see it's annotated with mutation here. And this description is what would show up in the schema for us. Okay. You'll see also we've got this not null annotation here. Okay. And you see this is a normal bean validation annotation. And if we look back at the schema, I go to the docs, you'll see there's an exclamation point after the person input. And this person input, that's a long story, but that's an issue I think we may have resolved this in a different branch. But anyways, so that's the story there. So that's sort of how the backend is working. What I also can show is what's happening on the front end. So that was this is basically how the whole backend is written. So most of the work in this really had nothing to do with the GraphQL API, it had just to do with normal programming, right? And fun stuff with the reactive APIs, which are a different story. There, of course, is some configuration and things like that, but out of the box, there's not a whole lot you have to do. So on the front end, what we have is go to this. So on the front end, what we have is a TypeScript app that uses that Apollo elements feature. So there it is there, Apollo elements. And that's basically all it uses. There's nothing really special. The rest of the stuff is related to other features that we're using. And mostly this doesn't really use a fancy framework, it just uses lit, which is a lightweight framework for web components. Or lightweight library, they call it, web components. But if we look at the code, we don't want generated code. All right. So if we look at the code, and we'll look at the code that actually gets these sessions, okay. Okay. So in the initial callback here, so let me find the actual part that is the query. Profile. Okay. And of course, I don't remember exactly where this is. Okay, so I don't think it's in this one. Okay, here we go. You can find it somewhere. Okay, so this is the method that actually loads the speaker profile. And basically, you know, there's some error handling and fun stuff like that. But at the end of the day, this is really what we're interested in. So this is GraphQL.query speaker profile. So GraphQL here is to find, where did it go? Okay, let me find, there it is. Okay, so this is pulled from GraphQL, which is a utility class that we have. And this utility class has the ability to do things like query speaker profile. And this query method essentially is using the controller. So lit has this notion of a reactive controller. And basically all we do is pass in the query, pass in the variables, and then get our data back. So so this controller is really what's doing the real work of actually making the query and everything for us. So if we look back to where this is being called, okay. So we're passing, we're doing this, the query speaker profile, this and the profile ID. The speaker profile query has a lot of our queries already built in a different class, which I would find somewhere. Yeah, it's not in here. Of course, I haven't looked at this code as much recently. But there is a graphical query that's built using that sort of GQL sort of syntax that we are essentially parameterizing here. So that's what I wanted to take away from. But as you can see, it's pretty straightforward. It's pretty much, you have an API that's used, you can create a query, pass in a query, get the results back. And then you can get them, if you're using TypeScript, you can get them as a type. Otherwise, you just get an object back you need to pull properties from. So that's basically the story there. All right, so we about at the end. I'd say we'll, Ryan, are there any questions there now?
No new questions.
Okay. All right, so I will go back to the slides.
So one quick question I have is, how do you set up GraphQL in an app? I mean, I saw where you did the POM import, but in terms of, binding it to a URL, where is that? Is there any setup? How much setup is involved with GraphQL?
There's really nothing different. It's just a norm. It just depends on whatever server you're using. So, with Quarkus, you basically just run Quarkus like normal, and it's exposed to the normal endpoint. And by default, it'll use the endpoint of actually, I think it's here. It'll be /GraphQL.
Oh, GraphQL.
I think that's probably configurable if you want to call it something else, but by default, it's just whatever port you put the server on /GraphQL.
And in terms of getting access to like credentials, like the users logged in, what users logged in, what's the tie-in with security like?
Right. It's like there's really nothing special about that kind of stuff. It's all kind of your normal things. So I think the only thing I'm not really sure with, I suspect, if you have like an authentication filter or something, I believe that's going to be more implementation question. So like,
Okay.
I know Quarkus uses, what is it called? It uses Vertex when it does reactive stuff.
Okay.
And what I don't know is like, okay, if I want to do a normal filter, like on top of Vertex, how does that work? If it's using, Jersey, I know what to do. So you got to think about it from that point of view. But once you've got those credentials, then it's really easy to just weave it in anywhere in your code, of course.
So do you know if it's implemented as like a servlet? So in your web.xml, can you lock it down? And
I think if you don't use the reactive bindings, I think you can it'll go through Jersey or REST easy, I think, for Quarkus. But again, that's going to depend on the implementation. So, and I suspect, and I think honestly, with any of them, they're going to be going through either a servlet or something like Vertex or something, right? I mean, there aren't a whole lot of options for Java. So
yeah, so can you inject like the servlet context or anything like that into your code that you're running, or?
I'm not sure if you can. That's again going to depend on the implementation. Like, so on macro profile GraphQL, I'm not 100% sure you can get a servlet context. The same way that, if you're using REST or, Jakarta REST or JAX-RS, you can't really get a servlet one, but you can get the REST one, so Yeah, so I'm not 100% sure. This is one of the areas we haven't gotten to yet for this project. I
Yeah.
know on the last one it was a completely different stack, so it was just all. But that was both on Jersey, and we ended up just doing it was simple, just use normal filters and stuff. Um, so
So it's kind of, which implementation you pick determines it's not standardized like the EE stuff.
exactly.
Jakarta EE
Exactly.
stuff. So there's different flavors, different features, and you really have to kind of research it first to figure out
Yeah, no,
what you're
I
using.
think, and I think, I suspect that once we get deeper into it, there's probably some sort of Quarkus guide that recommends how to do it with Micro Profile GraphQL.
Okay.
But I haven't gotten that far yet. But I'm gonna add that as a note because it's good to have some very specific answers. So I'll try and make sure next time I do this, I know like this framework does it this way, this framework does it this way.
Yeah.
This is my little note taking app. Okay. All right, cool. All right, so let me move on to the end here. So as usual, the GraphQL.org site has lots of different, higher level tools you can look at. So these are other tools. There's a pile of CLI, and actually there's a GraphQL CLI, which I've been meaning to look at. So I think it provides a lot of sort of general use features, but also there's obviously Swift in here. Angular has Apollo Angular, all sorts of different tools out there. And I also should mention that pretty much anything that's a graph database now provides a GraphQL API out of the box. So what's interesting about this is that you're seeing some more sort of old school client server solutions where it's like really you just talk to a GraphQL layer which talks directly to the database. You don't, there's not a whole lot of fancy code going on. So these are some options for that. And of course, Neo4j is one that's been around forever, but there's other ones too. And Hashura, I've not worked with, but they've done a good job of building out content. So I've been at their site a few times. So there's a few options there. Also, as you might imagine, this is a great area for whole, cloud providers. So Amazon has hopped in with AppSync. AppSync is, to me, their way of trying to simplify using all of their myriad of complicated APIs. And part of what it provides is the ability to create a GraphQL API and have it talk to all sorts of Amazon services. So you can talk to Lambdas, you can talk to databases, you can talk to all sorts of things. So I think that's a good option if you're already like in the Amazon sort of world and you have no intention of leaving. It could really simplify your life and could also make it really easy to create a BFF on top of existing services you're running on AWS. And Azure has something as well. I have not looked at that. StepZen has the approach of basically just allowing you to create a GraphQL API that integrates anything. So lots of REST services, lots of databases, etc. No real coding, just a lot of YAML configuration, and then magically it stitches everything together. So if you want to just expose a GraphQL API and you're not really, and you just have a lot of things you want to tie together, you might want to look at a managed approach as well. All right, so all that sounds great, but why would you not want to do this? Well, the first reason is that all the things that are great, right? It's a lot of extra overhead, right? If you just want to write an endpoint to get some data to return some, make a query and return some data back, you probably don't need all this stuff, right? And if you already know what you're doing and you're not having any problems with the rest, then you may not even need to switch. I mean, I think it's really more of finding the right solution for the right problem. And of course, a drawback is that it's not REST, so it's not as easy to work with out of the box. And you'll see once you know what you're doing, and you have, the working with it is not hard at all. But it is, it's different. It's not something everybody knows. And one of the things to keep in mind is that it is more magic. So a lot of the stuff that happens before it even gets to your code. Which some people really don't like. And also it can make it harder to debug sometimes, because sometimes you don't know if it's a bug in your code or a bug in the GraphQL code. I do want to point out that this is something I didn't mention earlier, is that GraphQL does have a way of handling errors, which is nice. So if I go, let me go back over here. So if I'm in here, right, and let's say I mess up this query. Let's say I put this in here. I'll get a validation error back. And this happens before it even gets to your code. This is done by the GraphQL engine. So it does validation and says, oh, this is not valid. There's no field called this here, right? And by the same token, if I do this and then I do ID foo, pass in a string instead of a number, an integer, I'll get another message saying it's not the right type, right? And what's interesting about GraphQL is that it will actually return data back to you if it can. So there's no data being returned. But if we're in a situation here where, let's say I put names here, right? So I'm specifying an incorrect property down here inside of sessions. And I go over here, complains validation error. Okay, actually in this scenario, we're not getting stuff back, but sometimes you'll still get partial data back, which is very useful in complicated UIs. You can have only part of it fail, not the whole thing. But the thing is that's overhead, right? Because it's doing all this validation up front, but it saves you time. So you don't have to validate anything at all. So. All right, so, and of course, you miss out on the benefits of REST, right? It's easy to get started. If you have a read-only or a low data API, I don't know if you really need GraphQL because, or if you're basically, if you have a write-only API, if it's mostly writes, you're not really getting a lot out of GraphQL. So, so something to keep in mind there. And finally, here are a whole bunch of resources. If you go to my speaker link, you can get a link to the slides that have all these links on them. But of course, there's the main GraphQL site. There's a couple articles on schema first approach versus non-schema first approach, and also tutorials and stuff like that as well. So that's pretty much it. So I will open it for any final questions.
The first question that we had that came in while we were talking was, what kind of persistent data storage is good with GraphQL?
I think it really depends. I don't think there's anything that's perfect for it. I think it depends on what you're building. So in the little app that we're building, we're using Postgres. On another project I worked on, we used DynamoDB. But I don't think it really matters that much. I do think, though, if you're trying to, gain some benefits from an existing GraphQL database, then an existing graph database or object database, obviously those map really well, but it really doesn't matter.
Okay, I don't see any other questions so far. Let me just quickly check the meetup. No questions there. So thank you for the presentation. I'll just give it another second for questions.
Okay.
If any more come in. Oh, nope, not yet. No, it looks very promising. So the code for the example app that you were showing, that's up, is that in one of the links?
You know what? I was thinking about that. The example I'm showing is not available, but I think I think the examples are the macro profile GraphQL example, this one down here.
Okay. And so you've been mainly working with Quarkus then?
Yeah.
Okay.
Yeah.
Any idea how far off is Quarkus from MicroProfile?
Oh, I would say it supports all the microprofile stuff. And
okay.
Add a lot of other crap that you can use or not. Some of it's really cool and some of it's like, I don't know if you know this stuff. So it's got really good testing too, though, which is nice. And integration with Docker and separate for testing. So that's nice. So.
Okay, so it doesn't look like we have any additional questions.
Okay.
Thank you for the presentation tonight, and thank you for the unexpected time change. I thought it was a coworker yesterday that clued me in that said, you know that your user group meeting is not at noon, it's at 7. So that was a bit of a surprise for me. But I think tonight this time actually worked out pretty well.
Yeah, it worked out okay.
So thank you very much. The recording will be up online. I believe YouTube keeps the recording up, so you can check it out later. I might try trimming down some of the beginning
Okay.
of it, and details on our next meeting will be up probably within the next week. So it'll be early February, it looks like right now, on JDK implementations. So
Cool.
with that, thank you, Keto,
All right.
and
Thanks for
see
having me.
everyone next month.
All
Bye.
right. Bye.